Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the inductive AC values from the Chapter 16 math handout problem number 17. And the type of problem that we have here is called a resistive inductive complex circuit. So let's look at the Chapter 16 math handout to see what values we have there. And we see on the Chapter 16 math handout, problem number 17, that we are given our total voltage, we are given our inductance of 18 millihenries, and we are given our resistance of 2.7 k ohms. I have for you here the steps, the order in which I solve each one of these values. So the first thing I'm going to do is solve XL. I'm going to use formula number 14 from the Chapter 16 formula handout to solve for my XL. XL equal to 2 pi FL. So 2 shift exponent button 2 pi times, here is my frequency, 15.915 kilohertz. Going back to the math handout just for a sec here, you see the frequency is right here in bold. That frequency will be used for problems number 17 through 24. Also on this problem, we have a new type of spreadsheet starting with number 17 here, and you will have to memorize how to write this out. Here is what the spreadsheet looks like. VT, VL, VR, IT, IL, IR, ZT, XL, R, and theta, Greek letter theta, Z. You will have to memorize how to write your spreadsheet here out for the test. So we get our spreadsheet written out, we fill in the values from the math handout, and we're ready to make some calculations. So 2 pi times my frequency of 15.915 kilohertz times L, 18 millihenries, and this gives me a resistance an XL inductive reactance value of 1.8 k ohms. The next thing I'm going to solve for is ZT. You see step number 2 here, ZT. I'm going to use formula number 19 from the formula handout. And if we look at the way the formula handout is written out, I've got the formulas associated with our complex inductive resistive circuits series right here, 17, 18, 19, 20. For resistive inductive complex parallel is 21, 22, 23, 24. Make sure you stick strictly to that. Do not use 21 through 24 for series. Use only 17 through 20. For parallel, do not use 17 through 20. Use only 21 through 24. So I need ZT. It's equal to the square root of R squared plus XL squared. So I'm going to first open square root. Here's the square root button. I open square root right here. Now I am going to put in my R of 2.7 times 10 to the third, and I'm going to square that number, squared, plus my XL of 1.8 times 10 to the third squared, XL squared. I'm going to hit equals engineering, and that gives me 3.24 k ohms for ZT. Now that I have ZT, I had VT, I can use Ohm's law to find IT. IT would be equal to VT divided by ZT. So 100 ohms divided by 3.24 times 10 to the third. Hit equals, hit engineering, and that would be 30.86 milliamps. As you see here on my third step, I can go ahead and fill in all my current. Formula 18 shows me that all the current stays the same in a series circuit. Once I do that, I can find VL using Ohm's law, IL times XL. So I have my 30.86 times 10 to the negative third times 1.8 times 10 to the third equals 55.55 volts. Now I'll do the 30.86 milliamps times 2.7K ohms equals 83.32 volts. Now I want to point out to you that you cannot add VL and VR together to check the VT. If we look at Formula 17, it shows you that it's the square root of VR squared plus VL squared. And that is because the voltage is going through these two different components out of phase. All right, how much out of phase? Well, that's what theta Z is going to tell us. Theta Z tells us the phase difference. So you have to hit shift. Here's our tangent button right here. That's for inverse tangent. We have to do inverse tangent. So again, that is shift tangent. And it's going to be XL. XL is going to go on top. 1.8 times 10 to the third. Hit over under. R is going to go on the bottom, as you see right here in Formula 20. 2.7 times 10 to the third. You're going to scroll over, close parentheses, hit equals. So theta Z is equal to 33.69 degrees. This is a degrees answer. You don't have to put degrees on the homework or on the test. All right, now that I've got all my calculations, I see the values that I'm asked for on the Canvas, on the Chapter 16 Canvas answer sheet assignment. So I would enter these values into the Chapter 16 Math Handout Canvas answer sheet assignment. Again, this is called a resistive inductive complex circuit. Resistive inductive series complex circuit. Thank you.